Hello students, welcome to RIMSc Academy. In this video we will discuss constant function. Let's start constant function. Okay, so constant function. Okay, so suppose a number fx is equal to k. Okay, is constant function. ओके इस टाइप के फंक्शन क्या होते हैं हमारे कांस्टेंट फंक्शन। कांस्टेंट फंक्शन का मतलब होता है कि अगर हम यहाँ पर x की कोई भी रियल वैल्यू पुट करें, हमेशा जो y की वैल्यू आएगी या fx की जो वैल्यू आएगी वो हमेशा क्या आएगी, k आएगी। यानी हम लोग इसको इस तरीके से भी कह सकते हैं, इट मीन्स फॉर ऑल वैल्यू ऑफ x इट रिमेन्स सेम। ओके, so it remains same for all value of x, it remains same. Suppose example लेते हैं, we put x is equal to 2023, right? So f of 2023 is equal to क्या आएगा, k, right? Suppose fx is equal to 5. Okay, so f of 10 is equal to 5, f of 15 is equal to 5, f of 2.555 is equal to 5. It means we can take any value of x, so the answer remains the same. Okay, so these types of function is called constant function. Okay, it's called constant function. So the second point is graph. So the graph is, suppose given function y is equal to 5. Okay, so we draw the graph, x-axis, okay. So now suppose this is x equal to 5. Okay, y equal to 5 लिया है, ठीक है। So this is y equal to 5. So this line is y is equal to 5. Okay, so this is fifth place, 5. Okay, it means the graph of constant function always parallel to x-axis or parallel to y-axis. Okay, suppose x is equal to 3. So here graph will this. Okay, so this is also a constant function. Okay, if we talking about its range, so range of function is 3. Okay, always 3, 5. Range of function is equal to 5. Okay, this value always 5. If we take any value of x, the answer will give 5, always 5. Okay, the answer will give always 5. Now we are talking domain of function, so we can put here whole x, whole r. Okay, so range, so domain of function is real number. Okay, now we take a question, fx is equal to given, okay, a cos square x plus sin to the power 4x upon cos to the power 4x plus sin square x, then f of 2023. okay, so हमको इसकी वैल्यू फाइंड करनी है. Okay, so now we will do the solution. Okay, so numerator is cos to the power 4x plus sin to the power 4x. Okay, so numerator क्या है, numerator is cos to the power 4x plus sin square x, right? We can write it cos square x plus 1 minus cos square x to the power whole square, right? We can write how actually sin square x is equal to 1 minus cos square x. Okay, and sorry, we are writing here something wrong. Actually this power is cos to the cos square x. Okay, so this is cos square x, and this is sine to the power 4x. Okay, so now here cos square x plus 1 plus, we are opening the square. Okay, so cos to the power 4x minus 2 cos square x. Okay, so here cos to the power 4x plus 1 minus cos square x. Okay, now 1 minus cos square x is equal to sin square x. So here cos to the power 4x plus sin square x. Okay, this is equal to denominator. So numerator is equal to denominator. So here fx is equal to 1, right? So f of 2023 is equal to 1. So this is the answer. Okay, so this is the answer. Okay, now we are taking few more questions. Suppose the question is if f of x is equal to mod of x minus 1 plus mod of x minus 5 is a constant function, is a constant function. Okay, so the question is this, and 1 less or x less or 5. Okay, and your x lies between 1 and 5. Okay, so the question asking fx is a constant function. Okay, so actually we are taking value from 1 and 5 between. Okay, so suppose we can take 2 3 4 5, anything else you want. Okay, and put here. Okay, you choose anything and put here. So you always give a positive value. Okay, positive value, and put any value between 1 and 5 and always give negative value, right? Negative value you can check also. Okay, suppose we are taking 3, so 3 minus 5 is equal to minus 5, right? So it's give negative, right? So f of x is equal to, now this is positive, so it comes as it is. Okay, so x minus 1, and this is negative, so it comes with negative signs. So x plus 5, right? So here x and x are cancels, here 4, so f of x is equal to 4. So this is a constant function, right? So this is a constant function. So the final answer is, yes, it is constant function. Constant function, right? So this is the final answer. Now we are moving with a few more questions, right? We can also say special constant function. Okay, so a special constant function, or simply constant function, just like. Okay, so a special constant function. Okay, so here a special constant function, actually nothing is special, but we are taking here a special because so important. Okay, so special. So now here question is, if f of x is equal to sine square x plus sine square x plus pi by 3 plus cos x into cos x plus pi by 3. Okay, and given g of 5 by 4 is equal to 1, then GOF of x is equal to, okay, so he is asking the value of GOF. Okay, GOF. Okay, so fx is given and g of 5 pi by 4 value is given. Okay, now we are doing solution. Okay, so actually given fx is equal to sine square x plus, okay, we can open it by sin a plus b formula. Okay, so sin a plus b is equal to, okay, so sin a plus b is equal to cos a plus sin b plus cos a into sin b. Okay, so here we can open it by sin a plus b formula. Okay, now so here comes 1 by 2 sin cos pi by 3 1 by 2. Okay, sin x plus root 3 by 2 sine pi by 3. Okay, sine pi by 3 is equal to root 3 by 2. Okay, here cos x and the whole square. Okay, now plus cos x and cos a plus b. So here cos a plus b is equal to cos a cos b minus sin a sin b, right? So we are writing here, so cos x into 1 by 2, so cos pi by 3 is equal to 1 by 2, right? Minus sin x into sin pi by 3 is equal to root 3 by 2, right? So this is the opening. Okay, now fx is equal to sin square x plus we are opening the square. Okay, so a square plus b square, right? So here a square plus b square plus 2ab. So here this is square, yani 1 by 4 sin square x plus this square, it means 3 by 4 cos square x plus the multiply and 2 times, so this is root 3 by 2 cos x plus sin x, right? Now plus cos x. Okay, now multiply this, so we are doing multiply, so this is 1 by 2 cos square x minus root 3 by 2 sin x into cos x, right? So this is into. Okay, so root 3 by 2 sin x cos x, root 3 by 2 sin x cos x, right? So this is cancelled here. So now remains 3 by 4 1 by 4 sin square x and sin square x, so this is 5 by 4 sin square x, right? Plus 3 by 4 cos square x and 1 by 2 cos square x, so this is also 5 by 4 cos square x. Okay, so we are taking common 5 by 4, so it remains sin square x plus cos square x, right? So this is a 1. So actually we know sin square x and cos square x is equal to 1. Okay, so this is the formula, trigonometric identities. So this is 1, and so the final answer is 5 by 4. So f of x is equal to 5 by 4. So this is our answer. Okay, not answer, actually he is asking GOF. Okay, so this is f of x. Okay, now we are finding g. We have given g of 5 by 4 is equal to 1, right? So 5 by 4, the value of 5 by 4 is f of x. So we are putting here f of x is equal to 1. So this is GOF of x is equal to 1, right? So this is the final answer, right? So this is the final result. Okay, so now this is a constant function, and just simple, fx is equal to k is a constant function. If we are putting any value of x, it remains constant. Just simple method. Okay, just simple thing you remember. So this is a constant function. Okay, now we are moving some more new topic. Okay, so next is exponential function. Okay, exponential function, right? So here we are taking point number 1, fx is equal to a to the power x is a exponential function. Okay, is a exponential function. It means we are saying a constant to the power variable type function is called constant function. Okay, sorry, exponential function. Okay, here constant is always greater than 0 and not equal to 1. Okay, and not equal to 1. If it is negative, then we cannot say it is exponential. Okay, so always positive. Actually its example is e to the power x, the famous, and pi to the power x, and 2 to the power x, 10 to the power x. Okay, these are the answers. Okay, Now actually why we are taking here negative, not negative. So let's see here. uh, 2 to the power x is right, okay, minus 2 to the power x is right, no problem, there is no problem, right? If we are taking minus 2 to the power 1 by 2, now this is root minus 2, so this is not actually defined, right? So this is not defined actually, so we cannot take here negative, okay, but in this case we can take here. So this is not definitely sure here we can take or not, okay, for the real number. So finally we cannot take the value of its negative, okay. Now now suppose we have given anywhere sine x to the power x. So it always remember, sine x is always greater than 0, because we cannot take here the value of negative, right? So now domain of x to the power x is equal to x, right? Because this is positive, right? And this is, so this is positive, so always take between 0 to infinite, so this is the range, right? Suppose we are saying there a is greater than 0 and not equal to 1, right? It means 0 less than a less than 1 and a is greater than 1, okay? These two cases are possible, okay, if value of a is less than 1 and greater than 0 and always greater than 1, okay, actually not equal to 1. So here this means 1 by 2 to the power x, 1 by 3 to the power x, right? 1 by e to the power x, right? So this is 2 to the power minus x, 3 to the power minus x, and e to the power minus x, right? So this is this type. Now we draw the graph, suppose like this, okay. So the graph will goes always like this, okay, never touch here. Oh, and this is 1 comma 0, sorry, 0 comma 1, right? So this is 0 comma 1. And now if we taking 8 greater than 1, so this is behave like e to the power x, 2 to the power x, 3 to the power x, pi to the power x, and 10 to the power x. Actually here how comes 1, right? You have doubt, so put value here. Actually here x is 0, right? So on the y-axis x is 0, so put x is equal to 0 anywhere. So 2 to the power minus 0, 2 to the power minus 0, actually 2 to the power 0, and 2 to the power 0 is 1, so always comes 1, okay. It means graph always go from here, okay, and it will like this, but go from here, right? So that not a big deal, okay. Now so if we are taking a greater than 1, right? So these functions are looks like this, right? So we are drawing the graph, okay. Now suppose, okay, the graph looks like this, okay. This is 0 comma 1, so e to the power, this is graph of e to the power x, and this graph is e to the power minus x, right? So we are taking if 0 here, okay, so y is 0, so it comes like this, okay. Okay. So now if someone asking you range of this type of function is always 0 to infinite, okay, 0 to infinite, never touch actually 0, okay. So we are taking here open 0, okay, so goes to infinite. So actually this is the range, okay, this distance is range, right? So this is from 0, not touching actually 0, so we are taking open 0 to infinite, goes to infinite, right? So goes to infinite. Also on this graph goes to infinite, but never touch 0, right? And if we are talking domain of function, so this is always real number. It means minus infinite to plus infinite, right? Because the value comes from whole R, right? So whole R, right? So this is range of function. Now we are taking a few questions, right? So the question is y is equal to 12 to the power x here, okay. So actually I always say I will done the mostly questions with graphs, not using theory. Okay, so this is graph. So actually here I will show you how we will draw the graph of exponential function, right? So now we are taking here uh, x less than 0. Okay, x less than 0. So here on this place actually x less than 0, right? On this place x always greater than 0, right? So this is a number line, this is a coordinate graph. Okay, so this is here x is less than 0, so we are taking x value less than 0, taking -1. So this is -1 here, so this is 1 by 12, right? So this is less than 1, right? Suppose this is 1. Okay, and we are taking x is equal to minus 2023. So this is y is equal to 1 upon 12 to the power 2023. So this is big number. Okay, so 1 upon big number is equal to small quantity. It means less than 1, very close to 0. Okay, so graph will comes right like this. Okay, and if now we are taking x greater than 0, then graph like this. Okay, so the my next question is, if we are taking here 13 to the power x, 14 to the power x, 15 to the power x, now the graph how will so now the graph will actually like this. But something is interesting here. Okay, actually uh, if we taking big value 12, 13, this is greater, this is 15, this is okay. So always remember 13 to the power x is less than 12 to the power x, less than 11 to the power x here. Okay, on the left side of 0. Okay, y axis, because here we are taking x less than 0. Okay, and here it's different. Okay, 13 to the power x greater than 12 to the power x greater than 11 to the power x, right? So here graph, so if we are drawing graph 12 to the power x here, so 12 to the power x is less than 11 to the power x. Actually this is also 12 to the power x, so we are drawing here 13 to the power x. Okay, so 13 to the power x is, so this is 13 to the, so 13 to the power x, it means we are taking some negative value, so it comes more less. Okay, so this graph comes like this. So here this, okay, this is 13 to the power x, right? If we are taking 14 to the power x, so graph will comes like this. Actually this sorry this. Okay, so this is, so this green line is 14 to the power x. Okay, so these are few graphs. Okay, so if we are saying 4 to the power x is greater than 5 to the power x, okay, it means it possible when x less than 0. Always remember, because here we already shown. Okay, 4 to the power x is greater than 5 to the power x, it means it possible when x equal to 0. So this remember always. Okay, actually this remember always, very important. So x less than 0. Okay, this case possible in x less than 0. Okay, and if we are taking 4 to the power x greater than 5 to the power x, so this case is possible on x less than 0. Okay, on x less than 0. So we are writing here something wrong. Okay, actually we are saying true but writing wrong. Okay, 13 less than 12. Okay, it means big quantity is less than small quantity, right? Big quantity less than small quantity here, right? And we are taking big quantity is less than small quantity, it means big quantity less than small, so x greater than 0, right? Actually we are writing true. here. Okay, so 4 to the power x less than 5 to the power x. So this possible when x less than 0. Okay, this case is possible when x less than 0, right? So this is here. Okay, and this is here. Okay, so this is here and this is here. Now, so always remember these important thing, okay, which help you always. So my question is, a domain of a square root of 2 to the power x minus 5 to the power x. Okay, so actually we know square root fx, uh, square root fx means fx is always greater than 0, right? It means 2 to the power x minus 5 to the power x always greater than 0. It means 2 to the power x greater than 5 to the power x here, right? Greater or equal to, actually greater or equal to. So here x less than 0. Okay, so in this case x less than 0, right? 2 to the power x greater than 5 to the power x, right? So 2 to the power x greater than 5 to the power x. It means we are taking here something wrong. Uh, x greater than 0, right? So it means x belongs to minus infinite to 0. X greater than 0. 0 to 0 to infinite. Okay, 0 to infinite. Actually, why we are taking here close? Because this gives greater or equal to, right? So this gives greater or equal to. Now we are moving few more questions. One more, sorry, one more topic. It means log. Okay, log function. Log function. Okay, log function. Actually, y is equal to log a to the power x, right? Here always remember a is greater than 0, not equal to 1, and x greater than 0. Okay, the value of x always greater than 0. So this is this always remember for the log. Okay, now we are drawing here graph of log x. Okay, so here there are two different case, right? Okay, so the first case is, so when a is greater than 0, it means 0 less than a less than 1, right? And the second case is a is greater than 1. The same case like exponential. Okay, so now we are drawing here graph of log x. Actually, this is y axis and this is x axis. Okay, now the graph of log x is like this. Okay, this is graph of log x. Now this is 1 comma 0. Okay, if we are putting a is x is equal to here x is equal to something, so it comes here on the x-axis y is equal to 0, right? So y is equal to 0, it means here comes y is equal to 0 is equal to log a to the power x, right? So log comes here, so it is e to the power 0 is equal to a to the power x, right? So sorry, 0 to the power x, and 0 to the power x 0, so a to the power x is equal to sorry x, a to the power sorry, something wrong here. Actually we are writing again, so this is x. Okay, so we log comes here, so this comes a to the power x is equal to, so here e to the power 0, right? So e to the power 0 is 1, so a to the power x is equal to 1 to the power 1, so x is equal to 1, right? So this is, so here comes 1, right? And if we are talking, so here we have shown the e to the power x is inverse of log x. Okay, so e to the power x and log x, log e to the power x are inverse function to each other, right? So it means inverse function are mirror image of each other line y equal to x, right? So if we drawing the graph, so here we are drawing graph, so it comes, sorry, like this. Okay, and suppose this is y is equal to x. Okay, so this is y is equal to x now, and sorry, now this is 0 comma 1 and this is 1 comma 0, right? So this graph is e to the power x. Okay, this graph is log e to the power x, right? So this is mirror y is equal to x. Now actually this graph is I'm not telling here, now this graph. Okay, so we copy here, not fully copied actually. Now leave, we will draw. Okay, so a is always greater, when a is always greater than 0, then graphs looks like this. Okay, so this is 0 1 comma 0, right? So this is 1 comma 0. So now this always greater than 0 for, okay, so this is graph for always a is greater than 0, because e to the power x is something 3 point. Okay, so always greater than 1. Okay, e is always greater than 1, right? uh, it means when any function y is equal to x mirror image purchase, then the inverse image, then it is called inverse image. Okay, so it is called inverse image. So now some properties of log and different, so we are not dealing with this. Okay, so you can also search on Google or previous video of my